Hey, I'm a pretty dumb guy. I figured out my mic was off for the entire time, and I have been talking since the last 10 minutes to Oblivion. Awesome. Uh, I'm really sorry if anybody is watching right now. Sorry. Yeah. We can continue. So I'll quickly go over it. The plan today is to keep continuing working on the Blind75 problems. For the Blind75 problems, I have finished off 17 of them. I'm gonna go from below, the bottom of the list today, and see how many we can capture, how many we can do. It's again 12:34 here at my time. It's pretty late in the night, so I still have to figure out proper timings and schedules for the streams and everything, balancing, life, job, and things like that. But right now, yeah, let's just see if we can do 5 of those. It should be a good one. Okay, should be a good one. So we started off with valid palindrome. A phrase is a palindrome, so we're talking about phrases, not words. But the idea remains the same, that it has to read the same from forward and back. But only thing is that it has to be case insensitive. So as an example, A and A will be a match here because it's just case insensitive matching. And you only consider characters and numbers, alphanumeric sets, right? So A will be okay. So you have a space and you have M, you skip over space because you don't consider that and you move forward. So here's what my plan is. What we are going to do is we are going to have 2 pointers here and here, and if it is alpha, if it is not an alpha, we're going to move the pointer either to the right or to the left depending on what kind of situation it is, right? Like if this is the pointer that you're going to move this right. If this is the pointer, you have to move to the left. Okay. That's right. If this is okay, I just played my video on the phone. Oh, sorry, my bad. But yeah, okay. So now, so now on the other side, if it is an alpha, what we have to do is we have to make a comparison. But right before we make the comparison, what I do want to do is, skip this over because it's a space, so we can skip over. We already actually did that. My bad. Sorry. So okay, we are talking about comparing this. So let's say this was a capital M, and we reach here and here, or we can talk about this first thing also, right? How we can do that is, if the character is equal to the character, we are good. Or characters, or I believe it's 32 by 20. So I don't quite remember. So ordinal of A, we can just do 65, 32, 97. Yeah. And strangely, comes up as 32. Okay, so I don't know if that was intentional or there's some maths behind it. I still have to figure that out. But yeah, it just works. So what we can do is we can say if is equal to, I'm writing both CH, but just consider CH1, CH2, or CH1 is equal to CH2 is all 32. If all of these are correct, you move forward. If any one of these fails, it's an issue, right? It's an issue. So we can think in that way. Just 1 second. I'm gonna take. Hello. Let's just stop the music for a second here. Hello. Okay, I guess there was some issue with mic and somebody told me that and we fixed that. I hope so. Anyways, we are gonna power through with the solutions, but I also want to get the solutions done for obvious reasons, right? Let me just give this. Okay, cool. So that's what the solution is gonna be. Okay, so let's quickly code it up. Uh, so I have blasted out the fonts on my IDE. It's really big for me. I mean, it's still workable, not that much, but okay. But just let me know on the chat if this is okay, because I felt in the previous ones the usual thing that I use is not quite readable. I suppose this is better. Okay, yeah. Let me just drop the music a little bit. Okay, cool. Go here. And you have this. Okay, so here's one thing, right? Sorry. Let's just say I need to, the first thing I need to know is an alpha, right? I believe everybody has something is alphabetic. I'm not quite sure if alphabetic is what we are looking for. Determines the special characters of alphabetic. Characters transfer alphabetic as a general category provided by get type is one of the uppercase, lowercase, title case, modifier, other letter number. Not quite sure what on earth is modifier. General category element indigo specification. Okay, I am not quite sure what that is you're talking about. How come there is no alphanumeric? Is character. Okay, so we're just gonna simply do that. Okay, private boolean is alpha, and you can have a character and return the character is thanks ID for all the clean stuff for me and the thing. Okay, and you can simply on earth are you talking about? Why is it trying to simplify things to? Oh, because I'm an idiot. It has to be odd, right? You cannot have every one of them in scope. So yeah, okay, cool. So now a very simple question here is that how do we do this stuff, right? Left is 0, right is s left minus 1, y left is best and right. Okay, so if you look at here, the first thing is this, right? If character ch is, so let's just call it ch1, just gonna call it left and ch right. Okay, that's how I'm gonna call those. So if sorry, if ch left is alpha ch left, it's not. I'm gonna simply do left plus plus. Okay, I'm gonna say boolean skip is false. So skip is true. CH. Right. So right minus minus. If skip, I can simply continue. Well, I could have not done this step, but I'm just doing it because in the same go I want to figure out on both sides. It really doesn't save any time on a greater scale, but yeah, if you're doing micro optimizations, maybe that actually saves time. I'm not very certain on that. We have to look at bytecode and how the execution flow will be. But yeah, anyways, it really doesn't matter much on how. Why is it not that? What you're talking about? False is always inverted. So what can I do? Okay. Next thing is this particular thing, right? So what we have to do here is that if ch left is equal to ch right, or ch left 32 is equal to ch right, or ch left is equal to ch right, 2. Actually, if all of these fail, we can simply return false. And this is how it generally it should work. What is happening? Okay. Hello man, what's up? Hey, thanks for joining it so late. Or catch and run. Just trying this out, that's all. Thanks for joining. Okay, meanwhile, your response, I'm quickly gonna go forward and see if that worked. Okay, that worked. We do a submit and again pray to God. God is great. Be good. I want to quickly do the thing that we do. Ask ChatGPT to give a revision note so that you can always come back and don't have to look at the entire code. A quick look at your notes should give you a pointer. This is basically like, people make cards or things like that, I think. Forever. Hey Shrine, you're still there? Oh, look at that. We have 5 watching. Wow, I never thought that 5 people would be watching me. Thank you everyone for joining. I don't know how to see or if I can even see who you are, but if you say hello in the chat, that would be great. Moving forward. Okay. Okay, you know what? I'm just gonna go back to the actual view. That's more easier to see. Okay, cool. Coming back. So this is done. We can move forward. Binary tree maximum pass on. This is a very interesting problem. Yeah, it's a very interesting problem. A path in the binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. Okay, it's just a definition of usual path. It's nonsense. I mean, it's not relevant to your problem. A node can appear in the sequence at node smarts. So any node given a single path, you cannot, So if I start from 1, I can go to 2, I can go to 3. These are 2 different paths. I cannot say that, hey, I go from 1, I go to 2, I come back to 1. Okay, that's not a valid path in the context of this problem. Okay, so if I have to cover all the nodes, I have to start from 2 go to 1 and 3, or the other way around, I start from 3. Okay, so the path sum of a path is the sum of thank you. If you're leaving, chalo, good night, bye bye. Thanks for dropping by. Hey, move with us, hello. How are you doing? How's it going? How's your Friday night going? Okay, we can move on. I think. Okay, so the path sum of the path sum of a path is the sum of the node values in the path. Alright. Given the root of a binary tree, return the maximum path sum of any non-empty paths. Okay, so let's take an example of minus 10, 9, 20, 15, 7. Okay, I forgot. Minus 10, 9, 20. Minus 10. Why is it coming up so? Okay. 9. Is that 9, 20? 57. Now, what is a path sum? A path sum is, if you consider any two nodes, you can travel from this particular node to your source node to your destination node, and you can say that, hey, while I'm traveling, whatever nodes I am going through, that is basically my path, and I'm going to add up all the nodes in that particular path, and I can have multiple paths in that way. Whichever path is having the maximum sum is my answer, right? So as an example, let's say I start walking from 9. So one of the paths is I can walk from 9 to 10. Another path is I can start from 9 and stay at 9 itself. I do not go anywhere, right? So that is also a valid path. So one of the things is, if I just start here and like not move anywhere, 9 is something. If I go from here to here, it is minus 1. From here, I have multiple other options. I can go here, so that would become minus. So I'm still starting from 9. Okay, so do not consider starting from minus 10. I'm still starting from 9. From here, I can go here. Then another option is I go down to 20. Sorry, I go down to 20. So it is my 10, 19. Okay. From 20, I have two different options. I can either go down on this side, I can either go down this side. Okay, so if I went down on this side, it is 15, so it is 34. If I went down on this path, it is 20. What was this thing? Okay, so 26, 19. So if I started from 9, my usual highest number that I can reach is 34. And the path I need to take is 9, 10, 20, 15. Okay, that would give me a total of 34. But I can start from 10 also. Okay, I could have started from 10 also. So if I start from 10, hey, move with us, hello, I don't know if you're still here. I told you hi, but you never actually mentioned anything. So, okay, it would be good to say hi back. Shalom. So the next thing is, I can start from minus 10. So if I go from minus 10, I have an option to go down here, or I have an option to go down here. If I went down here, I already know it's minus 1. If I went down here, it's 10. So 10 is not there, so I'm just going to write it down now. From here again, I can take two paths. So if I went down this path, it would be 17. If I went down this path, it would be 25. 25. Right, so still 34 is the highest. I mean, I'm still not looking at it. I'm just trying to accumulate every possible path sum that I can generate, So I can take into account that, okay, I try and start from every other node, and I can travel through the entire tree And for every other node to be considered as a source, what are the different paths that I can generate and try and reach different destinations, Okay, so we can start from 20 next. If I start from 20, I can go down here. So 20 itself is a minus 10 itself is actually a thing, which I forgot. So in 20, 20 itself is a sum. If I go down here, it's 35. If I go down on the other side, it's 27. But I can go up also. There is no restriction on the direction that I go. But it would be as same as coming down from minus 10 to 20, right? So we already considered that somewhere here. So we don't need to consider that particular path. This last two things are, I can also start from minus 15 and 7. So 15 and 7 is missing ideas. So 15 and 7 I'm just going to write. These are the individual nodes. So you start there and you finish there, you don't move around. But what if we go back here? It's the same situation. You've already traversed the path, you already know the values, right? So you don't need to bother much about it. So it's 35, which is the clear winner, right? So even though you see you have traveled a longer path here, from 9 you went to 10, then you came here, then you came here, but the winner is just this. So it is always not the amount of steps you have taken or the amount of nodes you have done. It's also about the value on those paths. So it can be very much possible that there is a huge path with all negative values and the very last two nodes are positive, or a different path with just a single node saying it's a positive number. So that would be your highest, right? So if you look at this answer should be 35, the answer is 42. So we definitely messed up something. Oh yeah, I forgot this. From 15 you went to 20, we messed it up here because from 20 you can also come down to 7. So this can be a bad path. So it's 35, 42, my bad. So 42 is actually the answer. Okay. So how do we solve this? One of the solutions is you go to every node and you try and traverse the entire tree from that node. So you consider 9 and then all the other nodes are your destination. Consider minus 10, all the other nodes are your destination. So this is how you have to do it. That would not be a great solution and efficient solution. Specifically, there are a huge number of nodes, right? So take this into consideration that we never from 20, the main reason why my brain missed out this particular step was because I was saying, hey, I already visited 20, so I know all the paths. I don't know all the paths, right? But I completely forgot that I had to write it down. But the concept is still the same, that hey, you already traveled certain paths, so why do you need to recompute those things? So as an example, if I went from 9 to 10 and then in the second iteration I take minus 10 as the root node and I try traversing to different other nodes, why should I be even calculating minus 10 to 9? I should already know that hey, I traversed this path and the weight of this path, I mean the path sum of this path is minus 1. So I should be knowing that, right? So we'll try to leverage that part and figure out a solution. Okay, so let's just redraw the graph, the tree. This here was 9, this was 20, this was 15, this was 7. Okay, cool. So now, what we do here is, let's say I start at the leaf nodes. What is the maximum path sum that I can have here? What is the maximum? It's the values itself. 9, 15, 7. That's it. Now, this 9 can go up here. There'll be a single parent, right? There cannot be multiple parents. There'll be a single parent, so you can only go. So you went up. For 10, what is the maximum path sum that you can generate? The maximum path sum that you can have here is, first of all, you can have minus 10. Right? You can have minus 10. So let's actually keep minus 10 aside. I think this is a better candidate to figure out. What is the maximum path sum here? It can be 20. Because the value itself is 20, I just stay there. I don't go anywhere. 20. 3 points, right? You're staying there, you get 20 points. Think of it like that. But from here, if I take in terms of what is the maximum path sum that I can generate from my subtrees? I'm not going to look up my parents right now. So usually with trees, the pattern is that you look at what you can do with your subtrees. Okay, what kind of results you can get back from your subtrees through which you can make a decision. See, this is one viable path. From 20, you came down to 50. From 20, you came down to 50. So 20 plus 50. This is another viable path. So this is 20 plus 7. But this is also another viable path. 15, 27, or the other way around. 7, 20, 50, right? I can take this into a consideration. So it is 20 plus 15 plus 7. Out of all this, whatever is the max value, I can say that is the maximum path sum I can generate at this node. Okay? Hopefully that makes sense. Sorry. Hopefully that makes sense. Okay. Someone is blasting their mouse outside at 1 o'clock. Anyways, it's not really uncommon. Why am I thinking in that way? But okay. So, if you take into consideration what is the max that you can generate at a single node, max of and type node value plus max from left tree, node value plus max from right tree, node value plus max from left tree plus max from right tree. Okay, so at any given point of node, this would be the formula that we can use to figure out what is the max path sum at that node. Right? What is the max path sum at that particular node? And we can have a global state where we can say, okay, this is where we are always gonna consider the maximum sum that you can generate, right? So it's usually like just a state that you're maintaining, and you can do a math.max. Okay. Now, the second question should be, I'm very curious to see why this guy said hello trainer, because do I know this guy? I feel like not quite sure. Feels like I know him. Or maybe I don't. Anyways. Okay. So now the question is, 15 return back the value 15. 7 return back the value 7. What should this guy return back? This guy should return back that what is the maximum sum at your node if I take a path down here. Will it be the same thing? No. If you look carefully, from the parent you can come down to this node and stay there. Okay? If I can remove stuff here without messing around with the... Okay, I can. Okay, so if I come down here I can stay here. That is one possibility. The second way is I come down here and I go down this way. The third way is I come down here and I go down this way. So if you look at it, if I just come down and stay here, this is the value, node val. If I go along the pink path, it's basically left tree. If I go along the right path, it's right tree. So I cannot consider going down both left and right. I can consider it to understand what is the maximum path sum I can have at that node. But for a parent, that is not a viable option. The reason why we take this is we are just saying that, hey, from a parent side, I can go in a loop like this. Okay. Go on a loop like this. So that is where okay, anyways, so that is where we should say that, okay, if I consider the first three things, those three things are gonna make you say what value I should be returning from it. Okay, so this here is the maximum value at a particular node that you can have, the maximum path sum for any particular node. But for the value to be returned back to the parent, we only consider the first three. Okay, so this is gonna be the solution. Hopefully I explained that and hopefully you got it. Okay, binary tree max path sum. Okay, we first need the definition of tree node, and things would have been easily commented out by Leetcode. They don't do that, so that it's difficult for you to copy paste, I suppose. Okay, sorry. So I'm going to create a separate function. I'm going to create the same name. Okay, and here it's a very simple thing. If so let's call it node. Okay. Now of course this overload is not correct because of the fact that it's tree node and tree node, but we are going to make a change to that. If node dot left is null, right is null, we need to return node dot back. Right. Okay. Okay. Now we can simply say int left max path sum is 0 and right max path sum is 0. Now why do we consider 0? The reason we can consider it 0 is because we are adding stuff. Because if it's not null, we are not going to go that side. So adding 0 to this really doesn't make any difference. So we always initialize. Okay. If node dot left, can you do it? Okay. Okay, that is not correct. So I have to go down node dot left and node dot value. Left max path sum is this. Okay, and we can do a similar thing for node dot right. Right max path sum. Okay. Okay, so we need some more intuitive functions, right? So I'm just gonna say max and values. Int max is this, for this, and okay. So return max of node dot value, left max this thing, and right max. This is what we're going to return, but we never actually captured the value at this particular thing, right? Max path sum at node is max of node value left, right. So there's a little problem here. Because if I just do node value plus these two, node value will be added twice. Yeah, we can, we can say that. I mean, yeah, we can do that. We can do that. So we add these two. So it's basically twice node of val. I just segregated it one. Okay. But I want it to be a little bit more, I don't know, explicit. So I'm going to do it in this way. Copy paste this. And here I can copy paste these things. Val plus left plus right sum. Okay. This is how we can. But I know the maximum path, maximum sum at node. I need to capture it somehow. So this is where I'm going to pass in a reference. We cannot do closures. I mean, I think we can do closures. You have to research a little bit more because again, like I don't know how it's going to capture the variables from outside. Because from lambdas, it really cannot change. It has to be a constant variable, right? So usually what I do is that's pretty much it. Okay. So usually what you can do is max of right is equal and max path sum. That's pretty much it. And we're gonna have to call the function here. So call root max path sum ref. Here we need to make sure integer part invalid and return max path sum. Okay, so this is the problem. This is the problem. So yeah, this is the solution. There's a small problem here. Okay, there's a small problem here. There's a small problem here. Which says that hey, this particular guy, we are not capturing this here, which means this is going to be a problem because what if the actual maximum? So everything, this considered tree where this is minus, this is minus, this is minus, everything is minus except this. So only 15 is the answer. So we also have to capture this. Okay. Okay, so this is the solution. I think I have to delete this definition out here for things to work. And then in here, I can simply say this. So let's see if that works. Okay, it says wrong answer. Did I do something wrong in here? Let me see that. Yeah. It's calling the wrong method. Somehow it went close. I don't know how, but it's calling the wrong method. Okay, now it's fine. Okay. So I'm gonna submit this and I'm gonna quickly fix this in here. Okay, cool. So your solution is done. I'm gonna quickly ask ChatGPT to summarize it. Usually you can code this in 10 minutes, not even 10 minutes, but yeah, since we are discussing the problem, it takes a little while, but otherwise it probably takes you 10 minutes to do this. While ChatGPT says something, let's go ahead and work with the next problem, which is best time to buy. I thought I solved that, did I not solve it? Okay, I guess not. Best time to buy such stock. this is the node. Each node compute max path, including left plus right plus node. Track global reference by reference. Return the same only one side. Yeah, makes sense. Okay. Return max path starting at node only one side. Okay, it's fine. I guess. Node plus left plus right. Node plus left plus right. I guess that's a better thing to actually do. Yeah, that's a better way for me to at least quickly, remember that. Oh, this is how we. But anyways, best time to buy and sell a stock. You are given an array of prices, where prices is the price of a given stock on INT. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. Return the maximum profit you can achieve from this transaction. You cannot achieve any profit, return 0. So this is very important. You can do a single transaction. You can choose a single day to buy, and you can choose a single day in the future to sell. That's pretty much it. It cannot be like, okay, the price, there's a price difference now, so I make a profit of 2 rupees, and again on the next day the price drops, so I buy it, and again on the next day I can sell it. Now you have to choose 2 different days, right? So usually how I go about with this problem is a very simple question. Okay, so these are dynamic problem. I think it's a dynamic problem. Let's quickly go see the. Yeah, it's a dynamic problem thing. I don't know how my solution. Yeah, I could have done a dynamic problem, usual approach. Have recursion, ask a question about what are the different possible solutions at a certain place. But usually, what I do with this things are, I just ask a simple question and that worked. Okay. So first I say this. So this is the day when you can never sell. You have to buy this, right? So I say that okay, you buy at 7, and then I go back here. Is this less than 7? So if you bought at 7, and somehow you have the dates of your future prices, you have the future prices of the stock. So you go back here and you go down here and see, oh, this is 1, it's definitely less, so I don't care about this, I'm gonna buy this. So this is your buy. 5, it's higher, so I'm not gonna buy, I'm gonna sell it. But I'm gonna sell it virtually because again I know all the futuristic dates, so I'm just gonna try and figure out the best possible date to sell, given I have bought it at 1. So the profit I can make is 4. Okay. So if I sell it at 5, the profit I can make 3. It's still less than 1. So the profit I can make is 2. I come here. So 1, 6. Profit I can make is 5. I come here, it's still greater. It's still greater. So the profit I can make is 3. Okay. Just imagine, it's not really a correct practical thing, but let's say this was -6. It was -6 price of your stock. It's never gonna happen. It's not just to understand that okay, it's less than 1. No. So here when you would have gone, you would have done the same thing here. You say that, oh, I bought at something higher, I don't want to do that. So let's buy at -6 and see that if there's a future date where I can make some profit. Essentially what you're doing is, within 2 dips, you're trying to find out the maximum profit. So the question here is that, so your stock price went like this, it came down, it went like this. So within the dips, you're trying to find out that within the dip, is there certain so in here, what is the maximum profit I can make? In here, what is the maximum profit I can make? In here, what is the maximum profit I can make? And then out of all of those, you choose 1, which is 5. And the answer should be 5. The answer is 5. In here, you cannot make anything. So let's quickly code this up. best time to buy stock, buy and sell stock. Okay, cool. Its max profit is 0. Current max profit. We can ignore that again. Let's see. So int current, let's just call it buy price, is prices also. So we gotta save this. Well, this is this. So well, this is not production grade code. You would want to write certain validations around things. But then here, I guess it's fine. So for if I is 1, I less than prices length, I plus plus. If the prices is greater, this is where if the prices is greater, what you do is prices are 5 minus buy price. This is your profit. So you take that with maximum profit and try and find out the maximum, and you assign it back to the max profit. Else, buy prices, and we can extract this out at least. We have used quite a number of time. Current price, today's price, earn max profit. Okay, so that's gonna be the solution. Very easy, very simple. Okay, cool. We managed to solve 3 problems, I suppose, today. It was, oh, it's only 2. Why 2? Oh, because I had to submit this one. Yeah. Okay. So let me quickly submit. Meanwhile, ChatGPT can actually do the thing. Try the lowest price so far. Same. So this is the note. Cool. Let's move forward to meeting rooms. Okay. So what the question is, given an array of meeting time intervals where this is start to end, I'm guessing this is inclusive for the third brackets, determine if a person could attend all the meetings. Okay. Well, basically the question is if you have overlapping intervals, so you cannot, because there's an overlap. So yeah. What is the length? 10.4. Okay. So usually speaking, 10.4 can go with log n solution, time complexity with constants. There was some code force, yeah, right here. So 10 to the power 4 can be n squared. So I'm still going with n log. Okay. So this is something that I look at to at least figure out, oh, like what kind of solution I can try and approach looking at the given constants, you know. This is nothing practical to how you do things in actual production. This is always something where you do something in production, which is competitive programming productions. But yeah, okay, cool. So what we can do here is that we can do a sort. Okay, so we can do a simple sort, and we can say that okay, we're gonna sort with the start time, and if there's a match of start time, we're gonna sort it according to your end time. Okay, and then we are just gonna say, oh, this is 0:30. So the last time is 30 end time. If this particular start time is less than or equal to this, you cannot simply attend all meetings. Otherwise you simply move forward and keep changing. So let's say this was 50, this is 100. Yeah, you could have done so, change it to 50. You come here, this is 150, this is 200. Can you do it? You can do it. Cool. Okay, it's all good. This is how you generally would approach this problem. Okay. Yeah, so assertions are all given that each inner array is of length 2. We can take the same assertion. Start and end is just saying, and start is always less than end. Sorry, start is always less than end. So again, some of the assertions. So let's quickly go ahead and pull it up. What is it? Meeting. Also, this is a premium problem. I do have subscription, so if you do not have subscription, you can just simply Google up rules. You don't have to rules. Haha. So in meeting rooms, I don't know if this is the thing here, or one other thing I personally prefer here is that you can just say Leetcode. You have it right here. I'm a monster. So it tells you what exactly the problem is. You can actually solve it on your own. You really do not need a platform to solve it on it. You can solve it on your own and figure out it. So that is also one good skill to have, where you can simply code it from scratch yourself. Okay, nobody gives you the boilerplate to do that. Okay. Okay. Okay, first things first, let's do a sort. Arrays.sort intervals. So we need a comparator or comparing int array. So you're gonna sort with this, then you're gonna say then comparing. Then comparing. So int array 1, and that should be it. So int end time is interval 0 1. For int I just say if intervals 0 is less than equal to end time, you can simply return false. Else end time equal to math.max. Now why do we do max? Because well, you don't have to do that, because that scenario is not heavy. Okay, cool. This should do 2 seconds. Array index or box. Okay. If interval is calculated less than 2, you can do it. This field, why is it false? I suppose it's only less than not equal to. Yeah, okay. So they're not considering, so we consider that, okay, if you're ending at 2 o'clock, you can start a meeting at 2 o'clock. That is what they're expecting. Did they say that explicitly? And I didn't. Yeah, they don't say it explicitly. That's fine. So now, let ChatGPT do this work. Meanwhile, I think this is submitted fine. And then you have sum of 2 numbers. Okay. Given 2 numbers, return the sum without using the operator plus and minus. Okay. given two integers a and b, return the sum of the two integers without using operators plus. Okay, that's a pretty interesting problem. I think this needs some sort of. So I don't think I ever solved it before. Let me quickly see. Oh, I have solved it. Wow, I didn't even know. So I have to quite think it. One of the things we can do is we can break it down to digits and then add up the digits. And adding up the digits won't work because you cannot do a plus. So that's not going to work. What else can we do here, right? What else can we do here? Good question. Also, range is minus 1000 to 1000, so it can also be okay. So we cannot definitely do a bitwise AND, can we? Can we do it? It's 2 and 3. So if I say 2 and 3, 2 is basically 1 0, and this is 1. So we say this is 1 and 1 is 1. And this is this, so you have 0 and then 1 carry. And this is 5. What if I have to add 2 and minus 3? So let's do the other way around. 3 and minus 2. Right. So minus 2 would be so that is not minus 2. Okay. Teacher dot find string minus 2. Thank you. This is this. And then if you look at 3, why? Not bad. Left. Will it do it? 1. And then make it 32. Cannot do it. Okay. So 1, 1. And then you have this way. So if you start iterating and you say, oh, this is 1, this is 0. And then you have 1, 0. Similarly, you would go through it. So in here, if I say integer of 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 26. I did something wrong here. Okay. Okay. 1. And this here in actual Java for wrapping it around would be -1. Fascinating, right? Why can't you just wrap it, buddy? Integer dot parse int. So this is the radix. If I give this everything is fine. But 1 plus 1 is 0. Carry 1. Okay. This is not gonna work. Can you have some hints, buddy? No? This has bit malfunction. It's really, really simple. Okay, I think my brain is jammed right now. I'm gonna think about this problem and I'm gonna come back to try and solve this. Okay. So yeah. I'll try to come back tomorrow and solve this one. It's already 1:25. I'm very, very tired right now. I need to get some sleep. So we have solved 4 problems, which is not quite great. I quickly want to solve one problem and go to sleep for now. Just being okay. Anyways, okay. So for now, we can just close up. Thank you everyone who joined. It was a good session. It was a pretty good session. Thank you everyone for joining. And see you soon. Soon I'll be having proper schedules of when I do stream, and then I can have some posts so that I can have some posts beforehand so that if somebody is interested in joining can join in. I would also be making certain videos. I will not be making videos maybe later on, but I will not be making videos on some things like TSA problems or tutorials or something like that. I'm not interested in that, at least for now. What I'm more interested in is sharing my journey and documenting my journey and sharing my knowledge of what I'm understanding, working with something more senior level. So as an example, algorithms, but not for Leetcode, but for actually something which is solving a real life problem. So usually I work more on the full stack side. I have interest on system level programming also, but I'm not that great, so it has to be more recreational there. So things like, okay, how do you do co-op? How do you integrate with Google? How do you do Google login? What are the different kind of paths that you can take if you're doing Google login? Do you handle things by yourself? Do you just Spring Boot take care of it? How have I integrated in some of the open source applications that I've worked on, or some of the open source projects that I'm currently trying to publish under my name, where I have simple SaaS like products, things like that. But yeah, that's pretty much the plan. And thank you everyone who have joined. Shrine, I hope you had a good time. Thanks for joining. Move with us, I hope you are good too. I am good. And thank you everyone. Thank you and have a good night or good morning wherever you are. Thank you. Bye bye.